Hello, students. So let's do some examples where we use our all or any functions inside functions because they can come in quite handy. Um, so let's do some stuff with sets. So uh, these are built-in functions, but that we haven't introduced. But let's write them ourselves because we can do it. So let's write a function called isSubset, and it takes in two sets. And what I want it to do is I want it to return true if A is a subset of B. Okay, so there's many ways we could do this. What I want is I want for every single element in A, I want to check to make sure it's in B. So that I need it for all the elements of A. So that gives me a hint. I might want to use the all function. Okay, and I'll put a little I is in B for I in A. So what this is going to do is it's going to take all the i's and a's and in A, and it's going to check to see if they're all in B. And let's see if it works. Is subset just, well, let's convince you it works. Maybe you're convinced already. And let's just try another example where we say take out the 3 here, and that's not going to be a subset because 3 was not in this set, but it was in this set. So, okay, Uh, that's a nice example of all. What if I do any? This is no longer going to be his subset, but what would that do? So what we're doing here is we're checking to see if any of the elements are in B. So this is really checking to see whether there's something in A that's in B. That means the two sets overlap. That means they intersect. So, or I don't know, let's think of a good name. Um, well, let's just call it intersect. Intersects, I guess. So this turns true if A and B have some intersection. So for instance, if I do this, that's going to be false because I still have is subset there. But if I ask if these intersect, sure they do. But if I remove the 2 here and make it a 1, they no longer intersect, and that's going to be false. Okay, so suppose I want to know if they are disjoint. So are disjoint A and B. So that means they have nothing in common. Well, either they intersect or they're disjoint. So what I could do is I could actually use the function I just made, return, functions can't have more than one separate word. That's where we're using underscores. So naming functions can't use multiple words. Nice that that came up. Okay, but anyway, let's run this and let's say are disjoint. This should be true because they are disjoint. As you see, it's true. As soon as I make something in both, it becomes false. So those are some nice examples of all and any. And there's many ways that we can do these things. Um, let's actually work on some of the standard functions in set theory, like unions and intersections and stuff. So suppose I don't want to tell whether or not two sets intersect. I actually want to get the intersection. Okay, so let's try creating the intersection. That's why I call this one intersects, like intersects, yes or no? Intersection, that's a thing. So I want the intersection of A and B. So that's all the things that are in both. Now, we might get tripped up thinking about this in our head, but really, I only have to iterate over one set, right? In order to get the things that are in both, I could take the things in A that are in B, or I could take the things in B that are in A. Either way, that's going to work. So I don't have to iterate over two different things. So all I have to do is get the set of I for I in A if I is in B. And that's going to work nicely. Let's try it. Let's try the intersection of, let's try these two. 4. 4 is the intersection of those two sets. And let's try another example. Let's try taking this out. 8, 5, nothing, an empty set. And if I give it the same thing twice in a row, 1, 4, let's see, 1, 4, well, that's fine. 1, 4, 1, 4. What about set minus? That's when you take the things in one set that's not in another. Well, if you did this, you can do set minus easily because we can actually just remove it. So these are the set of I that are in A if they're not in B. So we're basically removing the stuff in B if it's not in A. And let's try that. 1, 2, 3, 4. So I'm set minusing B. So none of the elements in B should appear here. I want everything in A that's not in B. And what do we get? Well, we get 1 and 2, because 1 and 2 are in A, and 1 and 2 are not in B. Okay, suppose, well, we've done intersection, the next thing we might want to think of is union. And union's a little trickier to create by hand with our tools because I don't just want the eyes that are in A, and I just don't just want the eyes that are in B, I want the eyes that are in both. So how do I iterate through this? Well, first of all, Python has built-ins for all of these. I'm just trying to think about whether we can create them on our own right now. And we can convert lists to sets and sets to lists. And we can combine lists, right, with concatenation. So define union of A and B. So what we could do is we could take the list of A and the list of B together. That's going to be the list of everything in A and then everything in B on the end, and I could just return that into a set. Not going to be as fast as the built-in union function, but let's just try this. Let's say we have, well, let's do this right here. And what do we get? We get everything that's in one or the other. Now, Python has built-in operators for this and other ways of doing this as well. If I do this vertical bar, that is union, and if I do this and sign here, that is intersection. So we didn't really need to make all of these, but I wanted to show you that we could, and that it wasn't too tricky in order to do so.